I'm Anil Kumar, and in this video I'm going to discuss parallel and perpendicular lines in details with a couple of examples. Let's first talk about what we know about lines from previous classes. We have been seeing this equation y equals to mx plus b, where m is the slope. So if I have equation y equals to 2 over 3x plus say let's say 5, then we know that the slope m is 2 over 3. Now for parallel lines, slope is same, right? Parallel lines have same slope. So if I write equation as y equals to 2 over 3x plus something else, let's say 7, the lines are parallel, correct? As far as perpendicular lines are concerned, what should be the slope? For a perpendicular line, we actually do negative reciprocal. Negative and reciprocal means flip this. It becomes 3 over 2x and any other point, maybe 7 also. We could take any point. Let's take 4. So that becomes perpendicular, right? So that is how we had been doing parallel and perpendicular lines. We just do negative reciprocal to find the perpendicular, and we use exactly same slope for the lines to be parallel. Now when we talk about vectors, the principle is same, right? So the principle is exactly same. Let me just share with you with the help of a small sketch. So if I have this line 2 over 3x plus 5, for example, it basically means that we can draw it like this. We have y-intercept of 5. We go up 2 units, 1, 2, and 3 on the right. So 1, 2, 3 kind of, right? So that's the slope. So we can draw a line which is kind of like this. Right, so this is the line which I have sketched just now, where this point here is assumed to be at 5, and that line is y equals to 2 over 3x plus 5. In vectors, we define a line with the help of a point and the direction, right? So in this case, the point P, let's say initial point P, is considered to be 0, 5, and the direction M is change in x, we say first, right? Change in x is 3, and then change in y, which is 2, correct? So that becomes the direction. Normally, we write this direction vector with reference to the origin. So let me sketch this direction here. So we'll go 3 units, 2x, which is 1, 2, 3 from origin, 2 up, 1, 2, and then draw this vector, correct? So this vector here from the origin O represents direction of this line, which is 3, 2. You get the idea, correct? So now any line with direction vector, we can say k times 3, 2 will be parallel, correct? So what we can do is, if I have this line, let's say line, or let's say xy equals to 0, 5 plus t times 3, 2, then any other line, let's say line 2, which could be written as xy, any other point. You could write y-intercepts, not a bad idea. Let's say 0, 7, as we took in the other case, plus t times 3, 2, right? That makes sense. Now you will notice that sometimes I'm writing these kinds of brackets. So whenever I write the square brackets, we're talking about actually So this is like position vector, right? So if I have to show this, so I'll show this like another line like this. So 0, 7 is actually coordinate point, but when I show with this vector, this becomes the vector. Do you see? O, let me call this point as B. OB. So this becomes OB for me. And I'm moving in this direction. So I'm moving in this direction t times. Do you see that? So plus t times, so OB is my vector, position vector, and then it is t times 3, 2, which is that direction. Correct? So that becomes a line, and these two lines you can see are parallel. Is it okay? So this is the very basic concept of parallel lines. What do we do for perpendicular lines in vectors? Now for perpendicular lines, if we have two vectors m1 and m2, their dot product should be 0. That is very important. Then the perpendicular, I mean these directions are perpendicular, right? As you can see, I can always have a direction. If I flip this, it becomes what? It becomes 2. Let me flip 2, and one of them, let me make it negative. So let me make 2 as negative since I have more space on this side. So I'll do -2 and 3. Okay. So -2 means 1, 2 units, and 3 means 1, 2, 3. So what I get here is a vector in this direction. Do you see that? As you can see, even from my rough sketch, they seem to be perpendicular, right? So in R2, it is kind of easy to get to the normal vector, to the given vector, just by interchanging the position and also one of the signs. You can test it out. So what we say here is that the perpendicular vector here in this case was -2, 3. And therefore, perpendicular line could be, we could use any point, right? Let's say we use a point 2, 3, right? Plus t times -2, 3. So it's that simple to get perpendicular line. So this line is perpendicular to given line L1. So if I say this line is L2, then L1 is perpendicular to L2. Well, you can confirm the direction vector for L1 is 3, 2, right? 3, 2. And the dot product with -2, 3 will give you what? 3 times -2 is -6. 2 times 3 is +6. When you add them, you get 0, right? So we have just confirmed that m1 dot m2 is also 0. So with this example and a short introduction, I think I've introduced you to R2 parallel perpendicular lines, right? We'll move forward and take some examples. So I have quite a few examples based on the request from the students. You can always pause the video, answer the questions yourself, and then check with my solution. Okay, so we'll begin one by one. Question number 1. Determine the vector equation of each line. First, parallel to y-axis and through a point. Interesting. So when I say parallel to y-axis and through a given point, which is 2, -5, somewhere here, so parallel to y-axis will be a line like this. Do you see that? It is important to sketch and visualize. That's key to success in vectors. Parallel to y-axis through this point. So we could write this equation as, as xy equals to the given point, which is 2 -5. Since it is parallel to y-axis, how does it move? It moves along y direction, nothing along x. So 0, 1. Do you see that? Simple as that. So this is the direction. So this is that direction. Do you see that? So it just moves along the y. So these two lines are parallel. I hope the concept is clear. Okay. B. Perpendicular to the given line and through this point. Now here we are given the equation in Cartesian form, right? So from this we know normal is what? Normal is 4 - 3, right? And therefore the direction perpendicular will be what? We'll flip this, change one of the signs. It becomes 3, 4. And therefore the equation will be So I'm writing all these equations in vector equation form. You can actually write it in other forms also, just for practice. Okay, so it is minus 3, 4. You could use any letter here, T or S. It doesn't really matter. It's just, you can say T belongs to real numbers, and I'll write S belongs to real numbers in this case, correct? S belongs, it's important to include. The last question here is parallel to 3, 5 minus plus T times 4 minus 3 with x-intercept at minus 10. So take your time to write it down, and here is the equation. You could also write this as xy equals to x-intercept at minus 10 means y is 0, correct? Plus we can write t, and parallel means same direction, which is 4 minus 3. Does it make sense to you? Where t belongs to real numbers, right? So that should be simple, but important to understand the concepts, right? Let's move on. Here is question number 2 for us. Consider the line L1 and L2. For what value of k are the lines parallel? For what value of k are the lines perpendicular? Now this is very important question from test point of view. You can pause the video, try it out, and then look into my suggestions, right? So when we say parallel means scalar multiples, so that means direction vectors are scalar multiple, right? Very important. So that's the concept. That means these two directions, 4 minus 5, should be equal to some scalar, let's say p times 7k. That is what it means. Now it gives me two different equations, right? So the first equation here will be, we have to solve these two equations to get the answer. So we have 7p equals to 4. That gives us p equals to 4 over 7, correct? If I write p equals to 4 over 7, the second part should be true, which is minus 5 should be equals to 4 over 7 times k. Is it okay? So that gives you the value of k. So that gives me k as equals to minus 35 over 4, correct? So for part A, I get k equals to minus 35 over 4. Okay, so these are the steps involved. I had to squeeze it in anyway. Part B, for what value of k are the lines perpendicular? Now when we say perpendicular, that means dot product is 0, right? So we say m1 dot m2 is equal to 0. That is the concept, correct? So let's do it. So we get 4 minus 5 dot, this one is 7k equals to 0. So 4 times 7 is 28 minus 5k, 5k equals to 0, and that gives us k equals to 28 divided by 5. So our answer is k equals to 28 divided by 5, right? Let's move on to the next question, which is question number 3. I hope you're finding it interesting. Share your views and questions, right? So let's continue. Now in question number 3, you have to determine if each vector is perpendicular to the line xyz equals to 3 minus 1, 5 plus t, 2 minus 3 minus 1. So we have two vectors here, vector A, 1 minus 1, 5, and B is 2, 1, 1. You can always pause the video, answer the question, and then look into my suggestions. So when we have to show that, then what basically we are doing is, this is our, let's say, direction M. In that case, we need to figure out the dot product, right? So M dot A dot, that should be 0 for the lines to be perpendicular, right? So that should be equal to 0 for the vectors to be perpendicular, correct? So that is the concept. Let's begin. So we have here 2 minus 3 minus 1. dot 1 minus 1, 5. So 2 times 1 is 2. Minus 1 minus 3 gives me plus 3. Minus 1 and 5 gives me minus 5. That is indeed 0. And therefore, we can write that A is perpendicular to the given line, right? So we can say to the line XYZ. Okay. For the next one, we'll again do the same exercise. That is 2 minus 3 minus 1 dot 2, 1, 1. So 2 times 2 is 4. Minus 3 times 1 is minus 3. Minus 1 times 1 is minus 1, which is 4 minus 4, which is also 0, right? So that means it is also perpendicular, right? So both are perpendicular. So that is B is also perpendicular to the given line, right? So let's say line 1. So we call this as line 1. So that is how you could do it. Just do the dot product and you will know whether they are perpendicular or not. You can take another point here. Let's say C as equal to 101 and test it out. Okay. Question number 4. Compare the lines in each pair. Are the lines parallel, perpendicular, or neither? So you know the concept. We have to basically do the dot product to find if they are perpendicular. For parallel, they should be scalar multiple. So the first line here is, just check the directions, right? That's kind of important area to check. What you notice here is that you could write this minus 8, 12, 20 as, you can write this as, if I take minus 2 common, I get minus 4, and here, minus 2 common gives me plus 4, and 12 gives me minus 3. So 6, sorry. Okay, 6 minus 6. But this gives me minus 10. Is it okay? Not minus 15. Since that is not matching, it is not parallel. So we know it is not parallel. Now, to show that they are perpendicular, we can do the dot product, correct? So you can do the dot product between these two. So let me do 4 minus 6 minus 15 dot. You could do with that also, or with minus 8, 12, 20, and you'll notice that this is also not equal to 0, so they are not parallel, not perpendicular also, okay? So the answer for first one is neither. Now let's do the next one. Well, clearly we do not have any scalar multiple, so we know they are not parallel, right? Let's check if they are perpendicular. So for that, let me do dot product. So we are doing dot product to figure out if they are perpendicular, right? So we have 5, 1 minus 5 dot 1, 5, 2. That gives me 5 times 1 is 5. 1 times 5 is again 5. Minus 5 times 2 is minus 10. That is indeed 0. So that means these are perpendicular lines. Perfect. So that is how you could do it. Of course, if they are perpendicular, they cannot be parallel, right? Okay. We are almost at the end of the video. Here's question number 5. Treat this as your test question. Determine the value of k for which the following lines are perpendicular. X minus 1 over k equals to y minus 2 over 2 equals to z plus 1 over k minus 1. So that's line 1 for you. And line 2 is given to you as x plus 3 over minus 2, z over 1, y equals to minus 1. You can pause the video, answer the question, and then look into my suggestions. Now, for line 1, what is the direction vector? Let me call this as M1. You can read straight from there. Direction vector is K, 2, and k minus 1. For line 2, what is the direction vector? So minus 2, correct. This is z, right? Not y. Y minus 1 is written at the end. So for y, it is divided by 0 actually. I mean, there's no change in y. I shouldn't say divide by 0, but no change, so 0. And for z, it is 1. So this is kind of a catch. Sometimes you can make a mistake here. Now we want perpendicular. Perpendicular means what? Means m1 dot m2 should be equal to 0, and that should help you to find the value of k. So let's do it. So we have k 2 k minus 1 dot minus 2 0 1. So k minus 2 gives minus 2k. 2 times 0 is 0. K minus 1 times 1 is k minus 1, and that should be equal to 0, right? So from here we get minus 2k plus k, which is minus k, minus 1 equals to 0, or we get k is equals to, bringing k to this side, minus 1. So that is our answer, right? So the answer is for k equals to minus 1, the two lines are perpendicular. So our answer is k equals to minus 1, right? I hope it is simple and very clear. Let's go to the last question, which is question number 6 in this particular set. Question number 6 here is, are the lines 2x minus 3y plus 15 equals to 0 and xy equals to 1, 6 plus t times 6, 4 parallel? You can always pause the video, answer the question. So, are they parallel? So, parallel means same slope, same direction vector, right? That is what. So, for the line which is 2x minus 3y plus 15 equals to 0, we know normal is 2 and minus 3. What is the direction? Let's call this as line 1. Direction will be, you can flip it, change one of the signs, so we make it positive. Perfect. Now let's work with the other equation. So the second equation given to us is xy equals to 1, 6 plus t 6, 4. So the direction vector here, we can call m2, is given to us as 6, 4. Note 6, 4, we can take 3 common. So we get 3, 2, or it's same as 3, 2. Same direction, right? Now since m1 is equal to m2, we have parallel lines. You get it, right? So at times you may be given direction vectors as scalar multiple. Scalar multiple means parallel, correct? Right? So this is a scalar multiple. Remember that part, scalar multiple means parallel, okay? So that is important to understand. So I hope that brings us to a good end by understanding how we can work with parallel and perpendicular lines, mainly in R2 for vectors. Thanks for watching and your patience. Feel free to post questions and your suggestions. All the best.